9.1, the Pythagorean theorem. Essential question: how can you prove the Pythagorean theorem? How do you use the Pythagorean theorem and its converse? The Pythagorean theorem has to be one of the most famous theorems in geometry, and it relates three numbers that are sides of a right triangle. Let's take a look at these two squares. They're squares. I can see that one side is a plus b and the other side is a plus b, as well as this other. Now, this is made up of regions, 4 triangles and 2 squares. This is made up of the same right triangles, but with a larger square. And so if you take away the purple area and left with the white area on this square, then it must be equal to the white area on this square. And that's what this area proof is supposed to be doing. Here's another area proof. When we work with a trapezoid here, a trapezoid with 2 right angles, and the height is a plus b, one base is a and one base is b. And we can go ahead and figure out the areas of each of these regions. Now, this first triangle is 1/2 base times height, which is a times b. And this triangle, which is the hypotenuse of this triangle and also the hypotenuse of this right triangle, it makes an isosceles right triangle. We can find its area, and we can find the area of the last one. Now we notice that these two areas can be put together, and then we can get a plus b. Now we can also get the area of the trapezoid by using the trapezoid formula. 1/2 height, this is the height, and then plus base 1 plus base 2. Now these two, when I multiply them together, create this. And if I distribute, then I get this. So these two areas should be equal to each other. And when we set them equal to each other, we're going to find that we're going to get the Pythagorean theorem. Let's go ahead and do that right now. Now I notice that I can subtract AB on both sides. And when I do that, that goes to 0, and I get 1/2 c squared. That's the same thing as 1/2 c squared equals 1/2 a squared plus 1/2 b squared. Now I'm going to multiply all sides by 2, and when I multiply all sides by 2, I get the Pythagorean theorem. So here is another proof using area. And here's the Pythagorean theorem. In a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Now, these are what we call Pythagorean triples. They are numbers that when you put them into the formula, c squared is equal to a squared plus b squared, it satisfies that. So for instance, if I take the number 5 and I square it, it's going to be equal to the other two numbers whose sum of the squares will equal the same thing. So this is equal to 25 is equal to 25. So these three numbers are sides of a right triangle. Now if I were to use the scale factor of 2 and double all the sides, I will still get a right triangle. And if I were to take these three numbers and triple it, I would still get a right triangle. Remember, in similarity, when you multiply by the scale factor, then you will still get a figure that is similar to it. So if it starts off being a right triangle, it'll end up being a right triangle. Now the other famous triples are 5, 12, 13, 8, 15, 17, 7, 24, 25. And there are more, but the numbers get a little bigger. Okay, let's go ahead and find the value of x and decide if this is a Pythagorean triple. So I'm going to take the hypotenuse, which is x squared, and take a leg, 5 squared plus 12 squared. I'm going to get x squared is equal to 169, so x is equal to 13. So this is 13. Now when all the numbers are integers, we call this a Pythagorean triple. So the answer is yes, it's a Pythagorean triple. Now if you end up memorizing some of these triples, then you don't have to go through all of this. You can just say 5, 12, and say 13 without having to go do the work. Now here's another problem, 7x, 14, and I've put the formula up and I substituted all the values, and I squared, got 147, took the square root, and notice this is not an integer. So I found x, that's what it has to do, find x, I did. but no, it's not a Pythagorean triple, and that's because they are not all integers. Okay, it's your turn now. Try to find x and decide if it's a Pythagorean triple, and then do the applied problem. Stop the screencast. And here are the answers. Number 1 is not a triple. Number 2, yes, that's a triple. That's a 3, 4, 5 right triangle. And number 3, here's the picture. I always like to draw a picture, then I can find the missing side. Okay, here's the converse of the Pythagorean theorem. It says if 3 numbers satisfy this relationship, then we can say it's a right triangle. So I've done this problem right here. What I'm trying to find out is if these 3 numbers satisfy the converse. So c squared, a squared plus b squared. And I don't know, I'm putting a question mark here. I don't know if they're equal. But I do know this is the biggest number. That number is 10 point something or other. So you always put the biggest number into the c spot. And then it doesn't matter about the other 2 numbers. I get 113 when I square it. I get, after I square these and add them together, I get 113. When these equal to each other, we say, yes, it's a right triangle. Now over here, I've started the problem, and I have to decide which is the biggest number. And if you put this in the calculator, you're going to find that's the biggest number. So I'm going to write 4 root 95 squared, and then I'm going to write 36 squared plus 15 squared. Now this, remember, square means you can write it out twice. So this is 4 root 95. And I'm just going to add up on the other side very quickly. And I'm getting 1521. Okay, so now I got to continue working here. I'm going to do 4. I'm going to rearrange the 4's in the front and the root 95's in the back. Now I know that when I multiply these 2 together, even if you put it in the calculator, you're going to find the answer is 95. Because a root 95 times a root 95 will just be 95. And then 4 times 4 is 16. So let me go ahead and put that in the calculator. And that answer is 1520, and remember the other side is 1521. These are not equal to each other, so the answer is no, not a right triangle. Okay, your turn. Go ahead and try to figure out if these are numbers that make a right triangle. Stop the screencast. And here are the answers. Notice I go ahead and put the largest number in the first spot. And when they're equal to each other, then we say yes. And if they're not equal to each other, we have to say no. The Pythagorean inequalities theorem says if 3 numbers satisfy this pattern right here, or this relationship, then we call it acute. So think of acute with the less than symbol. And if 3 numbers satisfy this relationship, we say it's obtuse. And notice obtuse is with the greater than symbol. Okay, so here's an example. I've put the c squared, a squared plus b squared. I put the largest number here for the square. I've got this, and I've noticed that 37.21 is less than 45.53. And when it's less than, then the conclusion is that it's acute. So the triangle is acute. When you have the less than symbol, it's acute. If it's equal, it's right. If it's greater, then it's obtuse. Okay, your turn to try to figure out whether it's acute, right, or obtuse. Stop the screencast to try these numbers. And here are the answers. Number 6 is an obtuse triangle, and number 7 ended up being a right triangle. This is the end of the screencast.